Right. So what we're doing is we're continuing our trig unit. We're going to be today we're going to be graphing sine and cosine. So we're going to be graphing trig functions the next few days. Now, it's not necessarily super hard math or anything. It's just a lot of new in-depth thinking kind of. Because you really want to understand what's going on, okay? So everybody, recall, on the unit circle, we're going to first focus on graphing y is equal to sine of x. In your notes, you should be writing that down. Now remember, on the unit circle, sine is our y value, so I'm going to direct your attention of what's happening on our y values. So I'm highlighting the y values. All right. Now, instead of graphing it on the unit circle, we're going to graph out on an XY chart what's happening here. Now, we're really graphing kind of like theta, and then I call it, instead of x, f of x, I call it theta, and then theta over time. So right here, we're at 0. So we're going to start at 0. Radians are 0 degrees. Let's just go with radians. So 0. At 0, our sine value is at 0, everybody. So that would be our first point we would want to plot on our XY chart, 0, 0. Now notice what's happening after that. We start going up, 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 and what's happening on sine? So we're going up, we're going from 0 up to a half, up to that decimal, up to that decimal, up to 1. So then I'm only going to plot pretty points. I don't want to plot every single one of those. That would take us forever. So what's the next prettiest point? This one. So at pi halves, we're now up to 1. We've climbed up to 1. So as we go this way, that was 0, up to pi half, we're up to 1. We are going higher, higher, higher until we went up to 1. Is everybody good? Now after that, after pi halves, we're going down to pi. Technically we're going up to pi. So we're going, after we hit 1, we're then going down, 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 till we hit 0 at pi. So at pi, we hit 0. At pi, we hit 0. So we were going down, 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 till we hit 0 at pi. Then from there, we're focusing on our y values. Now we're going into the negatives, 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 till at 3 pi halves, we hit -1. So we were going down, 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 till at 3 pi halves, we hit -1. And then after that, we're going negative, but upwards, 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 till we hit 0. At 2 pi, we're back up to 0. And there's our sinusoidal wave. That is literally the parent function for sine. You're going to want to remember that. So everybody, this is the parent function for sine. These points is what happens here. Couple things to notice about this is a pattern happened. Everybody, it went 0, 0. Let me change colors, sorry. The pattern happened, went 0, max, 0, min, 0. And that created one full cycle for sine. You're always going to hear me say that. Well, if we're graphing one full cycle, we've got to do 0, max, 0, min, 0. That is one full cycle. Is everybody good? All right, now a couple other things to notice. So notice the distance from here to here is the same, from here to here is the same. Look, pi halves, pi halves, pi halves, pi halves, correct? 1 pi half, 2 pi half, 3 pi half, 4 pi half. That distance is the same. Also notice, you see how this is what would be considered my midline. So midline is the halfway distance between the highest and lowest points. Does everybody see how the midline is? It's symmetrical over the midline. Everybody, do you see how it goes up to +1 and then below the midline, -1? All right. A little trick I use to help me remember what cycle for sine looks like, the 0, max, 0, min, 0, is I say, if you tilt your head sideways, squint one eye and close the other, do you see how that looks like a sideways S kind of for sine? It's a stupid trick. But it helps me remember. S starts in the middle, like 0, max, 0, min, 0, creating my S. All right, let's do cosine now. So everybody focusing now on the x values. The x values. Here we go. So these are our parent functions. So for y equals cosine of x. So at 0, our cosine starts up at 1. Everybody at 0, we start up at 1. Then our next pretty point, now notice from there we're climbing up, or we're actually going down, because this is a decimal smaller than 1. So we're going down, 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 till we hit 0. So at pi halves, we're at 0. Then at pi, we're at -1. So notice from 0, we then drop into the negative, negative, negatives till we hit -1. And then at 3 pi halves, we're back to 0. So we were going still negative, 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 but we were going up to 0. And then after that, after 3 pi halves, here's 2 pi. We're going from 0 up positive, 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 till we hit +1 at 2 pi. But 2 pi, we were back up at 1. So let's connect this. So the pattern that happens for cosine, this is a little trick, a full cycle for cosine is always this. Max, 0, min, 0, max. Look, max, 0, min, 0, max. Does everybody see? Which makes sense, because on the unit circle, our max value would be 1, our min would be -1. Is everybody seeing what I'm saying? Max, 0, min, 0, max. Now look, if you turn your head sideways and squint your eye and close the other, you see how it looks like a sideways C. It just helps me remember it starts at the top to create my C. Okay. Now guys, the parent function points are going to be really useful to us later, so we've got to get really good at making these, and the understanding should be pretty easy. Think about it. We're doing the 1, 2, 3, 4, 5 stops on the unit circle. 0, pi halves pi, 3 pi halves 2 pi. Does everybody see? And then from there, you would say the little pattern in your head for cosine. Max, 0, min, 0, max, and it makes it quick. And then for sine, you would do, that's the 0, max, 0, min, 0. Okay, cool. So look, I'm just going to show you how this, well, don't do this yet. I'm showing you how this works. Ooh, right here. So look, as I move this point around, okay, as I move this around, look, it's creating my sinusoidal wave. So look, boom, there's one cycle for sine and cosine. Now, couldn't I go around the unit circle again and create another sinusoidal wave? Then wouldn't that be, now I'm 2, 4 pi, right? It won't follow exactly where I'm pointing. But you get what I'm saying? Couldn't we go negative too? And create a negative sinusoidal wave, a negative cosine wave. Everybody good? So the wave is never stopping. So I need you to understand, like, let me just go back here. Really, we could sit and go again. That'd be up to 4 pi. We could go again. Again. Do you guys see my point here?
Yeah.
So that is why the domain is negative infinity to infinity. Then the range is between -1 and 1. It goes on forever. Same with sine. Okay, so here is sine and cosine graph. Here's some new vocabulary to know.
I was wondering, what, does that mean the maximum would be like 0?
We're going to have different amplitudes, and you'll see how that's going to work, yes. Okay, so here's some new words. So period. Hey, TA people, who's the girl with the red bow? You need a whisper. Thanks. I don't know her. So, period and amplitude. So period is physical length of one cycle. That is a word you need to, I always have to say that to myself. If I said, do you find the period? That means the physical length of one full cycle. Now remember, for sine, the physical length of one cycle would be the pattern 0, max, 0, min, 0, right? Everybody? So period means the physical length of one full cycle, which is that pattern. For cosine, one full cycle is max, 0, min, 0, max. Now, physical length means this length right here. So look at this. Isn't my period for just regular old sine from 0 to 2 pi? So my period is 2 pi, correct? Or 1 revolution. And then same with cosine. The length of one full cycle would be 2 pi. Now, we are going to take and start squishing these back in this way, changing the period. So let's say I took this dot and moved it, squish this back till this dot was here. Then wouldn't the period be now pi? Because period means length of one cycle. So that's what's going to happen when we start doing this, and you'll see how to do that. All right, our amplitude is how high you're down from the midline. Amplitude is distance. So amplitude is always positive. So notice it's up 1, down 1. So my amplitude is 1 from the midline. Same here. Midline would be here. So up 1, down 1. Amplitude is the halfway distance between the lowest and highest point, basically. Domain for sine and cosine is negative infinity to infinity, and the range is negative 1 to 1, including negative 1 and 1. Do we know what a period is? Do we know what amplitude is? Thank you. One full cycle. Yep, okay. So you're not going to take notes here. I'm going to go super quick. Here's what's going to be expected. You're going to be expected to graph not one, but at least 2 full cycles, just to get you graphing more than just one. So we could do this pretty quick here. If I was graphing 2 full cycles for sine, now remember, the pattern goes like this. 0 max, 0 min, 0 for sine, right? So that would be, think about it, how many quadrants are there? 1, 2, we're hitting 1, 2, 3, 4, correct? So everybody, that would mean we're going over 1, 2, 3, 4 tick marks would put me at 2 pi, right? That'd be 1 cycle. Does that make sense, everybody? So if I said you graph 2 cycles, you'd say that I need to go another 1, 2, 3, 4, and that would put me at 4 pi. Now look, it's easy. Cut it in half, we get a pi. Cut this in half, well, 1 pi, 2 pi, must be 3 pi here in distance, right? This cut in half is pi halves. We already know this though, right? This is the unit circle. And so look, 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, 5 pi halves, 6 pi halves, 7 pi halves. I filled in my x-axis. That would be the first thing you fill in, and then your amplitude, which is 1. So now we'd say, okay, sine's pattern goes 0, max, 0, min, 0. Go again. 0, max, 0, min, 0. And now I've graphed 2 full cycles for sine. Is anyone going to be mad if I just go ahead and graph cosine on that same, since that's going to be the same labels, right? Just graph cosine up here? Okay, I'm going to do that. So cosine is max, 0, min, 0, max. So here we go. Max, 0, min, 0, max. Max, 0, min, 0, max. And now I've drawn in 2 full cycles for cosine. We're going to ask you to draw in 2 cycles. All good? So isn't sine and cosine the same graph, really? Just one is shifted? Yeah, it is true. That is true. If I took, so sine starts at 0. If I took and brought this point, because it goes up first, right? If I shifted this back to here, they'd be the same graph. Okay, so here we go. Now we're going to change the amplitude. So amplitude is distance up or down from the midline, and it is the same as all other functions. If you have an a multiplied in front, that's a vertical stretch or a vertical compression. So that's what's going to happen, is vertically it's going to stretch it out or compress it. So the a in front is the amplitude. Now note, we look at the absolute value of that. Amplitude means distance, so we don't say negative amplitude. However, if there is a negative a, that just means a reflection over the x-axis, just like with all the other functions we've done this year. So let's look at my first example here. We have y is equal to 2 sine of x. That is literally a stretch of 2, just like all other functions, which means our amplitude is 2. So then from there, that didn't change anything on our x-axis. That just stretched out our y values. Instead of being up at 1, it's now going to be up at 2 and down to negative 2. So our x-axis will not change. Over 1, 2, 3, 4 tick marks puts me at, once again, 2 pi. 1, 2, 3, 4 puts me at 4 pi, and then we know filling this in how it goes. I'm not going to fill that in. We just did this. We just filled in that x-axis a second ago. However, on the test, on the homework, you do have to fill out every tick mark. Okay, let's go through the pattern here. It's sine. 0, max, 0, min, 0. It's hard to draw on such a big scale. 0, max, 0, min, 0. I probably didn't draw it perfectly up and down at 2, but I tried my best. Stretched out vertically. I just wanted to show you what they look like on the same graph. So the red one is regular old sine. The blue one is 2 sine of x. Do you see how they all fall? The x values fall in the exact same spot. It's just stretched out more. Okay, cool. All right, let's look at this one. What in the world? Okay, here we go. You're learning a new thing. Now we're going to have amplitude and period. So period, we've got to talk about this. So A is our amplitude. That's how high up or down from the midline. Now B is not the period. B is not the period. We have so many people say B is period. B is the number of cycles from 0 to 2 pi. Or another way to think of it is the frequency. How frequent it happens. Frequency, how frequent it happens. So B is the frequency or the number of cycles from 0 to 2 pi. So if we have this, y is equal to sine of 2x, what that literally is saying is we have 2 cycles from 0 to 2 pi. So now think about what that means. Sine's little, one cycle is 0, max, 0, min, 0. Correct? Now there's 1. Now 0, max, 0, min, 0. There's the second one, and that is over 0 to 2 pi. So like you were just saying, isn't that technically like compressed horizontally, everybody? Like this way? Or is it like more, I guess I should say kind of like stretched, right? Stretched horizontally, everybody, right? Are we good? So now there's 2 of those from 0 to 2 pi. So the number of cycles from 0 to 2 pi is the frequency. So how do we find the period? Now what does period mean? Period means physical length of just one of those cycles. So just one would have been the 0 max, 0 min, 0. So what would that be? What would the length of one cycle be? Pi, halfway through, correct everybody? To complete one cycle, it took half the amount of time. So it would be pi. Well, there's a formula to give you that. So here's the formula. Period is equal to 2 pi divided by b, which makes sense based on what we just said. So period is 2 pi divided by b. So look, it really does come out to be pi if we use the formula. Our period would be 2 pi divided by b, which is 2. Therefore, the length of one cycle is pi in length. Well, yep, that does make sense. All good with that. I'm trying to decide the right word is horizontally stretched or compressed. It's like horizontally like compressed, huh? Yeah. Because you see, normally from 0 to 2 pi we only have 1, and now it's pushed in this way. Okay, cool. Okay, so let's graph this one. Here we go. Everybody. So this is how it's literally just going to say graph. These are the steps I take to graph it accurately. I list out my amplitude. I talk about the number of cycles from 0 to 2 pi, and then I list out my period. So this is sine of 1/2 x. So my amplitude is 1. Good to know. The number of cycles from 0 to 2 pi, that's the b value, which is a half, everybody. There's a half of sine from 0 to 2 pi. So isn't that horizontally stretched out? It's like fold out. Well, let's figure out, I'm asking you to graph 2 cycles every time. Graph 2 cycles. So if I need to figure out what's the length of one cycle so that I can then graph 2 cycles. Well, period means length of one cycle. So we would do 2 pi divided by b. Dividing fractions is easy as pi. Flip the second and multiply. So the length of one cycle is 4 pi. Now this is going to really be important, and I remember this confused me when I was your age. So everybody listen to what I'm about to say. I'm going to write it out. we have a half a cycle from 0 to 2 pi. This is going to help for some more advanced ones we're going to get to in a minute. True, right? So doesn't that mean to create one cycle, it's going to take twice as long? Twice as much time, correct? To create one cycle. So wouldn't I be timesing by 2? If it's going to take twice as long to get one cycle, aren't I going to need to times these values by 2? My theta values by 2 to get a full cycle. Otherwise, we're not going to have a full cycle. Okay, cool. Now let's go ahead and graph this. So here we go. So starting at 0, our amplitude is up 1, down 1. That's the first thing I start with. Then I put in my tick marks. So I'm going over 1, 2, 3, 4. And that would put us at a length of 4 pi. I'm going to just stop there so everybody can see what we would do next. So then what would the halfway distance be? 0 to 4. Halfway would be 2 pi. So cutting this distance in half. Pi, 0. So this is 1 pi, 2 pi. This must be 3 pi. Why does that create one full cycle? Because the cycle for sine is 0 max, 0 min, 0. Here we go. Let's plot those points. 0 max, 0 min, 0. We've just graphed one cycle for sine. Not that hard, right? Now let's graph our second cycle here. So I'm going over 1, 2, 3, 4 tick marks, right? Now if this was 4 pi, then I'm going another length would be 8 pi. So what's halfway between 4 and 8? So this was 1, 2, 3, 4, 5 pi, 6 pi, 7 pi. And now I can continue the pattern. For sine, it's 0, max, 0, min, 0, and I've just graphed 2 cycles for the sine of 1/2 x. Now, I did not understand, this is not drawn to scale. What I mean by that is normally, don't we have a full sinusoidal wave all in here? Do you see how we're drawing it ourselves so it looks no different than the graph before? It's just our axis is labeled differently. But really, do you see how this is stretched out, guys, horizontally? Everybody see how it's stretched out horizontally? Okay, cool. I just want you to understand we're not drawing them to scale, obviously. That's just too hard to do. Okay, let's do another one. Here we go. Let's go quicker this time. All right, our amplitude would be 3. The number of cycles from 0 to 2 pi is 2. So we're going twice as fast, aren't we? Twice as fast. So our period, since I want to graph 2 cycles, let's figure out the length of one of those. 2 pi divided by 2, which is pi. That makes sense. Half as fast to get through a full cycle. Half the amount of time it needs. That's what's going to help you for harder stuff. So you would draw in your amplitude. 1, 2, 3. Down 1, 2, 3. Then we put in our tick marks. Over 1, 2, 3, 4 puts me at pi. Over 1, 2, 3, 4 would put me at 2 pi. Does everybody see why? Okay. Cutting these in half. Halfway would be pi halves, wouldn't it? So look, from here to here is 1 pi halves. That same amount is 2 pi halves. That same distance would be 3 pi halves. So then cutting these in half would be 1 pi fourths. 1 pi fourths, 2 pi fourths, 3 pi fourths. 4 pi fourths, 5 pi fourths, you gotta fill these in, 6 pi fourths, 7 pi fourths, 8 pi fourths. And now I would say, okay, cosine, it's really easy to miss and do the wrong one. Cosine is max, 0, min, 0, max. Here we go. Max, 0, min, 0, max. And there's our first cycle, taking half the amount of time it normally takes. Max, 0, min, 0, max. And look at that. There really was 2 full cycles from 0 to 2 pi. All good? We know, guys, keep arrows going because really it is continuing forever. Sweet. Can you do the next one by yourself? Just make sure you can go through it quick. Make sure it's easy to watch me do it. So just, I won't even go through it. If you can just label your axis right and go through and do it. Try it by yourself. Labeling the x-axis is always a little different doing it by yourself. Even you, or I'm going to take that flower and I'm going to snap it over your head.
It's already mixed, man. Hey, I heard you're going to the movies tonight. Is that with the spooky guy?
Nope.
Oh, really?
Different person.
Someone else? How many guys
Too many.
That's why you gotta focus on
Are you doing this?
I am. I'm a multitasker. I'm a marriage counselor and math performer at the same time.
Sweet.
So you got any questions?
Well, not particularly right now. I'll be thinking of.
Okay.
You're going to be able to check yours. You shouldn't be looking up here until you're checking your answer.
Hey, when would you get them?
I'm not telling you. You'll probably come and spy.
Why would I?
Because you're a little creeper.
No. Why would I spend?
I'm going to take notes for this part. Just watch. Because this is easy. So notice the amplitude is not negative. Our amplitude is 2. However, this is a reflection over the x-axis. So what you would do is you'd say, okay, amplitude is 2, negative 2, 1, 2, 3, 4, puts me at 2 pi, 1, 2, 3, 4, puts me at 4 pi. I'm not going to finish filling in this, however you would on a test. Now from there, you'd say sine usually goes like this. 0, max, 0, min, 0. Take, 0, more right there. So taking those points and reflecting them over the x-axis would bring this point down here, this point up here. So 0 would go over 0. So instead we'd go 0, min, 0, max, 0. The other way. So your pattern would just go backwards. So watch, you go 0, min, 0, max, 0. That would be reflecting it over x. 0, min, 0, max, 0. Okay. Do you guys need to try one by yourself with a negative and a cosine? You're sure? How sure are you? Just try, how about it will take you about 40 seconds. So why not just try to make sure you. So this is what your x-axis should look like. And then because it's negative cosine, you would say usually cosine is max, 0, min, 0, max. But now we got to go backwards. So it'll be instead min, 0, max, 0, min. Budding. Do you see how it's just backwards? Whoa. Min, 0, max, 0, min. Budding. Well, that's what it does. Okay, so let's get into the nitty gritty now. The big whammy schwammy. Taking notes. All right, everybody recall, we know how to shift all types of functions. You're not taking notes up here, you're thinking with your brain. Shifting for all functions works the same. So if I said to you, what's the shift? You would say right 1, up 3, stretch of 2 for the quadratic. If I said to you, what's this shift? You'd say left 1, down 4, stretch of 3, reflection over the x-axis. You'd say right 4, up 3, stretch of 2, reflection over the x. And you would say right 3, down 5, stretch of 4. Agreed? Yep. So we already know how to shift sine and cosine. It's just a little teeny bit, one little extra thing. So we know this is our amplitude, or a stretch or compression. B is the number of cycles from 0 to 2 pi, or the frequency, or how fast, the speed. And then our period, the length of just one of the cycles, is 2 pi divided by b, just like before. But now we're going to add in shifts left and right. Shifts left and right are grouped in with x, and we go opposite of the sign. Shifts up and down will be added on the outside of the function. The sign will stay the same. And then one thing to note is we do have to be careful. If we do have a b value that's not 1, and we have a shift left and right, we've got to take that into consideration, because you can't determine shifts left or right unless x is all by itself. So what we'll do is we'll end up factoring out a b, and like factoring it out of the terms. and then dividing both terms by b to see the true shift. So we've just got it. That's what this is saying. Be careful. We've got to look and make sure that x is all by itself and doesn't have a b in front. Then a negative is just a reflection over the x-axis. Okay, when you've got these down, we'll just start practicing these. They're actually not as hard as you might think. Especially because a lot of times we just use the tactic of using a parent function and applying the shifts. So it's pretty basic. Okay, here we go. Writing down your first example. Now keep in mind, it will just say graph. These are the steps I take and answer in my head every time or off on the side to be able to graph this correctly. So I go through and answer the amplitude, the number of cycles from 0 to 2 pi, the period, which means length of one cycle, and then your shifts left or right and your shifts up or down. So here we go. We would say our amplitude's a half. So on your graph, you would then go, okay, so I definitely know I need to go up a half unit and down negative a half. And then from there, you'd say the number of cycles from 0 to 2 pi. Well, isn't B 1? So there's one cycle from 0 to 2 pi. So 0 max, 0 min, 0. There's only one of those, and that's over 2 pi. So our period is 2 pi divided by b, which is 2 pi divided by 1, which is 2 pi, which makes sense. If there's only one cycle from 0 to 2 pi, the length of that would be 2 pi. And then we are shifting. Since that's just a 1, we're good to go. Aren't we shifting right pi thirds? And then there's no shift up or down. Does everyone agree? This is how we found it to be the easiest way, to literally take the parent function points and then shift them. So I would go right here and write down the parent function points. So we had a theta, and then what I called theta over time. And then our parent function points for y is equal to sine of x, you remember them. So let's think of the unit circle. 0, down up to pi halves, then over to pi, right, on the unit circle. 3 pi halves, and then 2 pi. And then remember, sine is 0, max, 0, min, 0. Does everybody see where I'm getting those parent function points from? Now we're applying these transformations. Well, the only one was we're timesing by a half, so think about it. That's a stretch. Wouldn't that be a y? Our y values are stretched out by a half. So we're going to times our y values by a half. And then aren't we going to right pi thirds units? That would take all your x values and add pi thirds to each of them. So it's pretty easy. Let's write down our new points. So everybody, I prefer if you just grab a calculator and everybody go quick so that we don't have to sit and think and get them wrong half the time. So look, 0 plus pi thirds is obviously pi thirds, right? 0 plus pi thirds. Everybody with me? Okay, now we're doing pi halves plus pi thirds. You would type in 1/2 plus 1/3, math, enter, enter. And you would get 5 pi 6. 1 pi plus pi thirds. That would be, okay, I'm crossing them out, 3 pi halves plus pi thirds. You guys all know how you could do it in your calculator? Okay. And then 2 pi plus pi thirds. Did we say 7 pi thirds? Okay, cool. Let's do these. 0 times a half is 0. 1 times a half is a half. Then negative 0 is 0, negative a half, and then 0. Now look, there's literally x, y points for us to graph. So literally, you would go in then and make your tick mark. Our first tick mark is at pi thirds. Our next one is at 5 pi 6. The next one's 4 pi thirds, and so on. Okay, if I said to graph 2 cycles, then you would go over only 4 more tick marks. Notice there's 5 right now, because normally we start at 0 and we go over 4, right? So look, 1, 2, 3, 4, 5, which makes sense because we shifted the 0 over. But now going another full cycle would just be going, because this is like our 0, 1, 2, 3, 4. So let's see if we can label that. Look for a pattern so you don't have to do too much math. Look for a pattern. 3, 6, 3, 6, 3. 6, 3, 6, 3. Next thing, obviously, there's a pi on top. And then let's see if we can figure out a pattern with my set, like the thirds and the 6. 7, 4. Wait, that's not a 7. That's a pi. Sorry. 1, 4, 7. What's happening? It happens to be adding 3, so let's just keep with that pattern. That's 7, 8, 9, 10. 13 then. Let's hope that's right. Okay, now how about the 6? 5, 11, 17, then 20, 23. Okay, cool. So now let's do our little, well, you guys, you don't even have to do the pattern. Why? Because you have points. Look, over pi thirds up 0. Do you see? Over 5 pi 6 up a half unit. I'm kind of going into the points. 4 pi thirds 0. 11 pi 6 negative a half. And then what? So look what happened. 0 max, 0 min, 0. So now I'm going to do that. 0 max, 0 min, 0. And I've graphed 2 cycles. Was that pretty dang easy for everybody? I thought so myself. Okay, next one. Now we're adding in some more stuff here. Getting more and more advanced. Don't be the person that calls the amplitude negative on the test. Amplitude's 3. Then I'll make myself a note, reflect over x. Now, the number of cycles from 0 to 2 pi is the b value, which is a third. There's a third, everybody think about this, there's a third of a cycle from 0 to 2 pi. A third of it. So I'm going to need 3 times the amount of normal to get through one full cycle. If I said you graph a full cycle, you're going to need 3 times the amount as normal. So just, does everybody see why? Did you notice I multiplied by the reciprocal when I said 3 times the amount to graph one cycle? Okay, cool. So let's just find our period. So our period is 2 pi divided by a third, which is 6 pi. Isn't that what we did? We had to have 3 times the normal amount, 0 to 2, to get through one full cycle. So 2, 4, 6. That's 3 times the amount. We are shifting no shift left or right, but we are shifting up 5 units. I literally have never taught this any year with transformations besides this year, because then it does kind of make it like foolproof, because it always works. So let's go through and do it that way. So let's hurry, quickly list out our parent function points. So let's go quick. 0, pi halves, pi, 3 pi halves, 2 pi. And now we would be at sine is 0, max, 0, min, 0. Now let's perform the transformations. Now here's what you have to remember. This is where people mess up. Multiplication comes before addition. So aren't we, our amplitude is net 3, and then we're also going to have a negative. So wouldn't that change your y values? It's a vertical stretch or compression, just like with all other functions. So we're going to times our y values by negative 3, everybody. So I'm going to cross that out. I've taken care of that transformation. Now this is what I remember I struggled with in high school, is trying to figure out what's going on here. Well, we just said this has to do with our period, doesn't it? Now that's like one, period means length of a full cycle. Aren't we going to need 3 times the amount like we just said? We're going to need to times all these by 3 then. Aren't we timesing by that's reciprocal? So we're going to times our x values by 3 to get through one full cycle. And then we're going to add 5, which would shift us up. Up would affect our y, so plus 5. So let's write down our new x, y points. Here we go. 0 times 3, 0. That times that. 3 pi halves. 3 pi. 9 pi halves. 6 pi. Cool. Now, and look at that. It's all matching up. Look, length of one cycle. Okay. Now we are going to 0 times negative 3 is 0 plus 5 is? Okay, anytime there was a 0, there'll be a 5. So wouldn't that be here? And here. All right, 1 times negative 3 plus 5. 2. And then negative 1 times negative 3 plus 5. 8. So we're just plotting those points. Now here's what I do next to make it easy on myself so that plotting the points is quicker. I go up and I say, okay, I was shifted up 5 units. Let's draw in. You do need to draw in your new midline. Up 1, 2, 3, 4, 5. At 5, I have a new midline. Then from there, my amplitude was up 3. So from there, we're going up 1, 2, 3. That would put me at 8. I like to draw in with my highlighter, like how high up I'm going to go, just so when I'm graphing the points, it's easier. And then down 1, 2, 3 will put me at 2. Now look, it's matching up. Highest point, lowest point. I use a highlighter to do that. And now we would fill in our x-axis, which literally is so easy since there it is. First point was 0. Next point, 3 pi halves. Next point, 3 pi. Next point, 9 pi halves. 6 pi. So now let's say I said to graph 2 cycles. I would go another 1, 2, 3, 4 tick marks and that'd be at 12 pi, would it not? So the halfway distance would be, look, 3, 6, 9 pi, and then think about it. You do this plus this divided by 2 to find the halfway distance. Would you not? Okay, cool. So 9 plus 6, 15 pi halves. That plus that divided by 2, 21 pi halves, and now I have enough, 21. Okay, here we go. Now all we have to do is plot points. Like we literally have the points. Over 0, up 5 is our first point. Over 3 pi halves, up to 2. 3 pi up to 5. 9 pi halves up to 8. And then 6 pi back to 5. Which, look, makes sense. 0, min, 0, max, 0. Since it was reflected, we went down first for sine. So then that same pattern will continue. 0, min, 0, and then max, and then back down to the new 0 that's been shifted. Okay. Was that too shabby? Was anyone like too lost?
No.
Okay. Careful. These are my last 2 examples here. Why do we have to be careful? Because look at this. If I said to you, what's the shift of this quadratic, and you said left 1, you'd be correct. If I said to you, what's the shift here, and you said left 1, you'd be wrong. Here's why. You have a 4. You can't determine the shift unless it's just x. So you'd factor out a 4. Do not pull out a 4. 4 was inside. You'd pull it out of the term, though. So then left in your parentheses is x plus 1/4. That's all square. So now you'd say left a 4, correct? Okay, cool. So right here, if I said to you, what are the shifts? You would say, right here, you'd say right pi, and you would be correct. However, if you said, and this is what we see on the test most, is people say right pi. 2, we got to pull out a 2. Don't pull it out. You would go like this. Sine of 2, divide by 2, divide by 2. So then left is x minus pi halves. So now you would say, it's a shift of right pi halves, but my frequency is a 2. So that would kind of take, we would take that into consideration as well. Yes. Yes. Yep, that'll be your frequency, which will then allow you to find your period, and then you're now shifting those points right after that pi half. Cool. Are we good? Okay, let's start putting, these are my last 2 examples. I personally would rewrite this in the prettier form. We know it's really just plus 3, so rewrite it. This is y is equal to negative cosine of 2x minus pi, and it's really plus 3. Okay, now we can answer all the shifts. Our amplitude is 1 with a reflection over x. Then we would say, okay, we're going up 3. Now we've got to go through and figure out how many cycles are from 0 to 2 pi. That's our b value, which is 2. Therefore, our period is 2 pi divided by 2, which is pi, which makes sense. If there's 2 cycles from 0 to 2 pi to complete one cycle, we'll take half the time, which makes sense of why our period is pi, correct? Cool, moving on. And now shift left or right. If you say right pi, you're wrong. It's really right. Okay, right pi halves. And now using the parent function for this one is definitely beneficial. Here we go. Quick. 0 pi halves, pi, 3 pi halves, 2 pi. For cosine though, it's max 0, min 0, max. So max 1, 0, min 0, max. There's the parent function for cosine. When performing the transformations, multiplication has to come before addition. If you do it the other way, it's going to be wrong. So we have to go through and figure out the multiplication transformations first. So if we're reflecting over the x-axis, that would be taking your y values and timesing them by -1. I've taken care of that transformation. Now the next thing that's going to change is this x-axis, right? Like, if you think about it. So we've got to change the length. Didn't we say it's going to take us half this normal time? This is the normal time, right? Half the normal time to complete one cycle. So that means we would take our x values and times them by a half. So that takes care of that. And now we're shifting up 3 units. That's a y shift. Add 3 after that. And then right pi halves. So after we times by a half, then we're going to then take those points and then shift them over pi halves units. So that would be an x shift plus pi half. So now, once again, let's get everybody helping so we can do it way quicker, writing down the new x, y points. Hey, everybody, let's get these points quick. 0 times a half plus pi halves. That one's easy, all right? Pi halves times a half, pi fourths, correct? Pi fourths plus pi halves is what? You guys are quick. Pi times a half, pi halves plus pi halves. Pi. 3 pi halves times 1 pi half is 3 pi fourths. 3 pi fourths plus pi halves. What is it? And then, 2 times a half is pi. Well, 2 pi times a half is pi. Pi plus pi halves is 3 pi halves. Hey, 1 times -1 plus 3 is? Anytime there's a 1, I'm going to put a 2, so I'm just going to go for that. 0 times -1 plus 3. 3, so then that must be 3 as well. -1 times -1 plus 3. 4. Okay, so now to graph that, we would go down, draw in your shift up and down. Move this down. Okay, so the first thing I do is, once again, go find my new midline. It was shifted up 3. Up 1, 2, 3. There's my new midline. Our amplitude from there was 1, was it? Okay. So then that'll be up 4 and then down at 2, which makes sense. Look, highest, lowest. I like to take my highlighter to make my graphing go quicker and smoother for me personally. And then I draw in my little picky tick mark. Could we do another 4 tick marks if we wanted? Yeah? If we wanted? Are we good with just 1 for right now? Okay, here we go. Plotting points, pretty easy stuff, because it literally just takes care of itself. Pi halves up 2. Agreed? Okay. We could go another 4 tick marks, but we won't, I guess. Okay. is the last example, and there is a reason we're doing it. Notice, so far, on all of our x-axes, it's always had a pi in it. We can't let it throw us off if the algebra has the pi's go away. So this will literally last example for it. So rewriting this once again in the prettiest format, y is equal to -2, sine of, and this one does have some weirdness. It just feels weird, but we have to just go with what we know. Then we still have +5. So everybody, my amplitude is 2. Then we would say we're also reflecting over x. Then from there, this is what throws people off. Because normally when I say, what's the number of cycles from 0 to 2 pi, we like to say there's 2 or a half. Like a number that makes sense. Well, B is the number of cycles from 0 to 2 pi. So there's 3 pi halves. So you have to think of it as distance. There's 3 pi halves amount of cycles from 0 to 2 pi. So we would just write 3 pi halves. Just go with it. Like we know that's B. Our period, let's use the formula for this one. 2 pi divided by B. B is 3 pi halves. So do your algebra right. Dividing fractions is easy as pi. We flip the second and multiply. So then notice what happens here. Pi's divide out. Our period, the length of one cycle is 4/3. So 1, 2, 3, 4 tick marks would be 4/3 in units. Like it would be over 4/3. Does that make sense? And then we're shifted up 5. And then luckily, there's no shift left or right, or else then we would have to go through and do the parent function. So if there was a shift left or right, I would list out my parent function points for sine. Then I would just do the transformations like we did on the last problem. This one's going to be easier since there's not a shift left and right. So is anyone mad if I just do it the easy way? Do you get what I'm saying though when I say you would just do it like the other one? You would list out the parent function points and you would just do that same process. Okay, here we go. Let's label our x-axis here. My amplitude is, it's shifted up 5. Up 1, 2, 3, 4, 5. Boom. Then my amplitude is, so I'd write in my new midline. My amplitude is up 1, 2. That would put me at 7. Down 1, 2 would put me at 3. And now labeling my x-axis. Because there's not a shift left or right, I can literally go like this. 1, 2, 3, 4 puts me at 4/3. Isn't that the length of the cycle? A period of length of a cycle. So now I could, once again, because I want to do 2 cycles, 1, 2, 3, 4. 4/3 plus 4/3 is 8/3. So then let's find the halfway distance. Right here. Oh, you're saying this is 2/3? Okay. So look, this is 1/3. So then look how easy. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 6/3, 7/3, 8/3. Okay, we have our x-axis labeled. Now because we're not using parent function points, because the parent function points takes care of the thinking for us, we would have to think this is a reflected sine. Normal sine does 0, max, 0, min, 0. Isn't that what sine normally looks like? So now instead, because it's reflected, I'm going to go 0, min, 0, max, 0, da-dink, 0, min, 0, max, and then back down to 0. I missed the point. That's okay. Yeah, I know it's hard to not draw on that point. Don't do it. Okay. All right, there's the assignment. Way to go. That went really good.